welcome. My name is Glenn Andrew. I'm a structural analyst here with SDA, more commonly known as Structures.aero. And I'll be telling y'all what's new in Simcenter Femap version 2021.1. So without further ado, let's get into it. And just before I get started, actually, the slides and a handout are available in the webinar software, so make sure to grab those as well. If you have any questions throughout the webinar, feel free to just type those into the chat, and I'll try to address those at the end. So, all right, let's get started. Okay, so I'll take y'all through a little bit of background of Structures.aero, and then get into the new functionality and updates. And then I've got a few demonstrations with 2021.1 just to show you some of these new updates and how they can be useful and how to actually access some of the new features. So, okay, so Structures.aero, we are a structural engineering consulting firm. We comprise of 19 engineers, and we've got a wide range of degree levels as well as degree categories, but we're primarily aerospace, mechanical, and engineering science mechanics degrees. We are all experts at Femap, and we use Femap and Nastran every day. And we've also got we've got a design wing that is fully competent in a wide range of CAD packages as well. So I guess keep in mind throughout the webinar that we provide like engineering services, and we can help you out in a lot of different ways. So, and software support is definitely one of them. So some recent projects that we've worked on in terms of on the space side, obviously the composite crew module. If you're familiar with SDA, that's something that we started work on a long time ago. And that was kind of like the beginning of Structures.aero. And we've worked on a lot of projects since then, including the Orion Heat Shield weight reduction program. We worked with Lockheed on the Orion Crew Module, the Service Module. We're currently working on the Roman Space Telescope, previously known as the W1st Telescope, as well as Blue Origin, Sierra Nevada. We work with a lot of partners in the space industry. As far as the aircraft industry, that's a big side of our business too. We've recently worked on the Boom Supersonic XB1 that commercially debuted for a big test campaign. So that was a really big achievement, and we're really proud of our work with them. We've worked with the Spaceship Company on White Knight 2, the commuter craft, Airbus, Vahana Quad VTOL, and the Piper M600, the new wing for that aircraft. And we also work on plenty of UAVs and other projects. So lots of experience there, primarily in design and analysis of composite structures. So in addition to being like a engineering consulting firm, we also are a Siemens Value-Added Reseller. So we sell all the software that we actually use, and then actually more than that as well. So in addition to selling the software, we also offer training classes, and actually there is a training class on February 1st through the 5th. It's online, it's all virtual, but it's the Introduction to Femap with NX Nastran class. So if anyone's interested in that class, there will be an email at the end of the webinar, as well as I think my email was at the beginning, and you can find it in one of the handouts as well. Or you can just go online and shoot us an email. So we also offer classes in advanced Femap training as well as Fibersim. And I guess one other thing to note here is that we actually have really good connections and friendships with the software writers. So if we don't actually know an answer, we can go directly to them and really figure out like a really technical detail of like why something is happening. So that's another advantage that we have. All right, let's get into the updates to Femap for this year. So in terms of pre-processing, there's a completely new toolbox introduced with 2021.1 called the Mesh Control Explorer. And it's an optional tool for managing your mesh connectivity and how your mesh propagates through disconnected geometry. So I think previous to this tool being introduced, at least for my workflow, I would get something like what's pictured, and then I'd have to non-manifold add all these surfaces together so that it's one solid. And that would ensure mesh connectivity across these edges, and that the mesh would match up and all that stuff. And with this new Mesh Control Explorer, it's actually no longer necessary to non-manifold add everything together. And this is actually beneficial in some cases where with the Parasolid engine, if things aren't exactly touching, then you may not, the non-manifold add command may not work properly. And yes, there is a search tolerance that you can change, but that's not really recommended. So this gives you the option that if your geometry isn't perfectly lining up, you can still handle that geometry without having to do a bunch of like extending the edges of your surface to what all intersects and then having to delete off those extra edges. So I think I actually will use this feature, especially if I have a lot of problems non-manifold adding and I really just want to connect something together fast. Additionally, in the Mesh Control Explorer toolbox, you can see which edges are paired together, but I think we'll go through that more in the next few slides. So one example is with shell meshing. If you have 5 separate standalone surfaces, the Mesh Control Explorer will automatically generate your mesh sizing and manage that so that any generated mesh will have coincident nodes that you can then merge, and that it'll propagate, like if you change a mesh sizing on one separate solid, it'll propagate across through different solids, which I'm pretty sure that's a new thing. I don't think you've ever been able to do that in previous versions of Femap. So yeah, obviously you can see here, we've got a mapped mesh and you can see all the lines. If you set the meshing attributes, the mesh size will change on the curves and it'll propagate along these shared edges, as I said earlier. So you can see if you change the mesh sizing, it does propagate through these disconnected solids. Okay, so this is what the toolbox actually looks like. You've got a lot of different options for turning the controller on and off. You can explore the options. You can show different surfaces that are mapped together. You can show edges that are paired by proximity. A lot of different options here. If you end up using this toolbox, definitely let us know, because we'd be glad to pass on any feedback to their software writers if there's a way to make it better. So for the options, you can actually change which solids are selected to propagate mesh sizings across. So if you don't want the mesh sizing to propagate through the entire model, you can select a few different surfaces and say, I only want this mesh to update, which is actually really useful if you have a bunch of rigids connected, because typically when you remesh and there's a rigid connected to your mesh, it will disconnect that rigid. Especially if you have mesh propagation options turned on, and it goes through like your entire mesh and disconnects all your rigids. That can be a big pain. So this is a little bit easier way to manage that type of thing. Yeah, again, there's the capability to manage a lot of shells, and you can see here there's a lot of different disconnected surfaces, and they're all different solids. And the key with this is that you can have high quality connected shell meshes. And as you can see here, that's actually like a really, really uniform mesh. So again, there's no need for major geometry manipulation as long as everything comes in as like a mid-surface already. Okay, so for the pre-processing hex mesh updates, I think this is probably where this Mesh Control Explorer is most helpful, because you can actually visualize which surfaces are mapped together. And if you need to, you can change that. Because previously, I don't think if you were hex meshing, you could do all the mapping, but I don't know if there was a way to actually visualize which surfaces are mapped together. So it's just a lot easier now to visualize that and correct it if problems happen on the back end. So here you can see you can decrease mesh sizing, and it'll propagate again across multiple solids if your solid is sliced up for hex meshing. And then there's also the capability for remeshing surfaces with, max quads or quad tri-layers, apply a mapped mesh to a previously free mesh surface. And this is one of the features that I'm actually going to demo. And then you can also propagate mesh, of course, across those solid boundaries. And here's an example. If you want to change this to a mapped mesh, you can see it changes here, but then also crosses over the solid into the next solid with a uniform and matching mesh. Okay, so moving right along, I think in maybe one of the last two updates, they introduced a mesh check interference command, and it was fairly rudimentary, and now they've added the option to add an interference factor or a proximity factor. And the interference factor shrinks the mesh by the value entered, and it makes it possible to ignore small amounts of interference to find the real problems. The proximity factor, it grows the mesh and helps you find cases where the mesh is very close but not really overlapping. And then there's also an option to create a group from that interference, so you can only show those and dig into different things that are going on in your model. And then just a small update. I think they've updated the algorithm that determines the center line of a curve, so that you can now define beam elements along that center line if you have just solid geometry. It just basically extracts the center line. That's it. And it's able to handle more complex geometry. So there's the resulting extracted curve, and then there's the elements applied to that. Okay, so there's another improvement to the mid-surfacing tool, the automatic tool. And basically, there's a problem where if you have rib thicknesses that are not the same, but they intersect at a junction, you may encounter flanges that overlap. And I'm going to demonstrate this one after this. But there's now a box that you can check which will repair those surfaces so that there's nothing overlapping. And I think this will just be more demonstrated by the demo. Okay, this is one of the biggest updates that I think. I really liked the direction that Femap was going in the previous update, where they brought in the functionality to send your table to Excel. But now they've added the ability to send your table to Excel and then connect it, so that when you edit your table in Excel, it automatically updates in Femap. I think that's awesome, because I use this all the time in 2020.2. But I always have to copy my table back into Femap. So this is just one extra step that I don't have to do. So there's a live option, and then there's an update option where if it's live, it'll just automatically populate in Femap. If you uncheck live, you have to click update to populate Femap. And that's probably for gigantic Excel tables where the dynamic update probably just takes it bogs down. So you may want to just uncheck live, do everything on Excel side, and throw it back into Femap with a click of a button. So this is one thing that I'm going to demo. Okay. Additionally, one extra feature with the Excel integration is that for cases where you have a drop-down box in the operation, that's also present in Excel, and it will also update. So I know when you're doing a linear combination, as is here, that's really helpful, because previously I had to type it in and then drag it all the way down in Excel and then copy and paste it back into Femap. And now it's just connected, and it knows that there's a Dropbox there. I think that's really cool. And I really like the direction that the Femap team is taking this, and I'm looking forward to see what other Excel integrations they can add to Femap. And yeah, you see here in Excel, the drop-down box is the same as in Femap. Okay, so there's a couple performance graphics improvements. For this update, they've just changed, they've added the support for RBE1 elements, and it's just a lot faster when you're picking and drawing degrees of freedom labels. So this is definitely a key theme with Femap updates, is that they've really focused on improving the efficiency of the software so that you can really use large models. And this is something that I really appreciate, because I've used models with like 1 million nodes and 1 million elements at some points. And it's really nice when they push out an update and all of a sudden like your workflow is so much faster, because you can actually box select like 1 million elements at once without it just like crashing Femap. So yeah, continued theme here. And then they've also upgraded the actual picking algorithms. The old scheme is still it's still available. I think it's off by default now, but you can turn it back on if like you notice you can't select something, or it's not working properly for you. There's not a lot of information on like what they've actually improved on the back end, but it's just it's supposed to be a lot better. And in future versions, the old scheme will just completely go away, but for now, it's still available. And you can see it's supposed to be 5 to 10 times faster in different things, as well as using a lot of different CPUs. So the big key takeaway here is that they're continuing to work on decreasing the amount of time it takes to like box select and pick different entities in the model, which I know can be very, very frustrating when you accidentally do that and you have to wait like 5 or 10 minutes for Femap to figure out what it's doing. Okay, and then kind of in the same vein, there's not a lot of point to showing you like 1 million entities in this listing box. So if you go over 1,000 unique ID ranges, it just tells you how many you've selected. And I think that's pretty smart, because no one's going to scroll through it like that more than 1,000 ID ranges. And yeah, here it shows you like what it looks like before, and it gives you the option to hide the list. Okay, this is actually a pretty cool feature. It's pretty basic, but like it's similar to in PowerPoint. If you want to match the color of one thing to another thing, there's an eyedropper feature. This is similar, but you can match the color to like a wide range of entities: points, curves, surfaces, elements, nodes, materials, properties. I know I'll definitely be using this, especially for like CAD when it all comes in like one color, or all random colors. You can select like all your bolts and match color to one and that type of thing. And then they've also improved the list groups command, where when you actually run this command, there's an option to evaluate the group. And it just checks to make sure your entity selection is valid, and it should throw an error, or at least tell you if it's not valid. Okay, so a short list of post-processing improvements. I know they've added the ability to control averaging of stresses across boundaries between linear and parabolic solid elements. And this is because they've recently added the ability to create like a mix of brick or hex meshes or TED meshes, and then actually change the order. So you can change whether you want to average results across those boundaries of like parabolic or linear elements and that type of thing. All right, getting into some solver support updates. I'm going to do a demo on this in a second, but the big key takeaway here is that if you're only running a linear analysis and you're not interested in all the other interfaces that Femap can support, you can turn off all those options, and then when you go to define a connection property, you won't be faced with like a big overwhelming amount of information. It'll filter out all like the specific ANSYS entries, so you can only focus on what you really need to enter for like Nastran. And similar, if you're only running like a multi-step structural simulation, you can turn everything else off, and it just simplifies, and you don't have to process as many inputs and wonder like, oh, do I have to fill this out? So it also increases the performance in displaying dialog boxes, but this applies to like connection properties, connection regions, analysis specific materials if you have like a 401 specific material for the new 401 solver, and then also property extensions. And you can also set this in Femap preferences and in the Femap model file. Okay, in terms of other solver support, the DDAM, which is Dynamic Design Analysis Method. So that Nastran interface has been improved a little bit. This is really used in shock response analysis due to like underwater detonations, so it's really of interest to naval and marine customers. But you can now access the cell mode card in Nastran through the Femap interface, so you can write that card out now. And it's here in this mode selection box. And then also they've added the capability to read in multi-point constraint forces, element strains, and membrane-only bending stresses for beams, as well as shells and composites. So they've added support for some result vectors coming out of a DDAM solution. And then this is requested with a param SHL MEM yes, and I think that would go in the bulk data entry. But it's important to note that composite laminates are supported in DDAM, but there is an error in Simcenter Nastran 2021.1 where it'll write the incorrect summed modal response data to the nastran.op2 file. So just make sure you're aware of that if you're a DDAM user. Okay, so there's also improvements in the modal frequency analysis. When I first looked at this, I wasn't super sure what it was, so I had to ask one of our more senior engineers, and he was actually really excited about this. So this is this gives you the option to filter out certain modes in your structure if you don't want to include them in your analysis. And the example that he gave was if you're running a flutter mode or a flutter analysis, you have to run the modes first in order to reduce the dimensionality of your problem. And if you get like a mode that you know isn't going to be present in your flutter solution, for example, like a random RBE that is attached to some idealized and also undesigned structure, and you know it's not going to participate if you actually model the real thing, you could filter out that mode and only include the real modes in your analysis. And it's not as much about improving the performance of your solution, but you don't have to consider those extra modes. So yeah, this is something that he was really excited about. Okay, and then as always, they add API updates. So they've added the analysis step object, which is used to control, analysis step options within a subcase for MSC Nastran. There's global step objects now, publish tool and publish table objects. If you're really interested in the API updates, make sure to check out the full release notes because I've had to condense and shorten them here to hit the highlights, but there's a lot of other stuff that I haven't been able to cover here. So as well, they've introduced a few more objects to the FE set object, which is super common in API writing. And instead of using the count method, which has a large number of entries, you can improve your performance by using the is not empty, the has one, or the has multiple IDs functions or methods. So these are also being used within Femap to improve performance. So if you have any APIs that take a long time to run and you know that it's because of certain count methods, this could be an option to improve performance. Okay, that's it for the update. The actual updates, I'm going to get to some demos in a second, but make sure if you have any questions, go ahead and type them into the box below and we'll get to them after the demos. And if you have any questions for me specifically, feel free to email me. And if you have any software specific questions or questions about pricing or would like to see a demo or anything, feel free to contact Keith. He's our director of sales. I know he's on the call right now. And yeah, we'd be happy to help you out. So without further ado, I'll get right into the demos. All right, so the first thing that I'll demo is the improvements to the mid-surface overlap repair function. So this is Femap 2020.1. It's got a new icon if you haven't noticed. I've turned on the big icons because I find them easier to click, and you can do that by going right-clicking in the menu, customize, user commands, actually, options, and there's an option for large icons. So we've got this fitting. Let's say we want to mid-surface it really fast. We can go to mid-surface, automatic, right here. And then I'm just going to go ahead and select all of the surfaces. I don't really feel like measuring any of these ribs, so I'm going to say they're probably about a 1/2 inch thick, which I've measured earlier. And I'm going to combine all the mid surfaces. So they're overlapping, so I'm going to turn off the original solid and focus in on the problem area, which I've already figured out previously. But if you can't see this, I'll try to zoom in. But for one, these ribs are two different thicknesses, so their mid surfaces show up on this web in different locations. That's not the problem that we're worried about. The problem is that if I look at the different surfaces that are here, actually look at the different solids. Oh, I added them together. Let me delete this and redo this. I'm going to select all. I think I turned on combined mid surfaces maybe. Yeah, okay, so they all show up, all the different surfaces. If I list my solids, there's one solid here and there's two solids here, and you can see they're actually overlapping, which is, that's not what we want. We want them to be, we don't want them to overlap. So that checkbox when you mid-surface will fix that problem for you. And as bonus content, I will actually show you how to fix that, this overlap or the rib mismatches. So if we turn that checkbox on, if we go to Geometry, Mid-Surface, Automatic, select all our surfaces, type in a 1/2 inch, check Overlap Repair, and let's just go ahead and combine our mid-surfaces. They're still not aligning, but we have fixed that issue where those two surfaces were overlapping. So let's say I want to fix that problem. I'm going to go ahead and delete geometry surface, delete one of them. I'm going to go to meshing, feature removal, surfaces. Actually, we already did that. So I'm going to remove the curves and delete the points because those will mess up my mesh sizing later on. And the whole reason that I'm trying to shift these two to line up at the same intersection is for mesh sizing, because that would drive my mesh sizing really far down, way lower than I suspect I would want to simulate. So then I could go to geometry, surface, ruled between curves, select these two, and there's the surface, and it's exactly teed up with the other flange. Okay, so now we can non-manifold edit into the solid. There's no free edges, but the surface isn't the same color as my solid. I want that color back. So here we can use the new match color feature, which I actually think this is going to be really helpful. We can modify color surface, select the surface, match color surface, and voila, there we go. Our surface matches. All right, that's the demo for those two features. Let's go ahead and get into this Mesh Control Explorer toolbox. So here I have a steering knuckle, and it's been hex meshed. It looks really clean actually. It just looks like a nice hex mesh. You can see it looks like this is a free mesh that was then basically extruded out to this surface. So I would bet these two surfaces are matched. But the solids, like if you wanted to hex mesh this, you have to slice it up into hex meshable solids. With a TET mesh, you don't have to slice it up. You can just bomb it, mesh the whole thing. But because you have to slice it up, then you have to match all these surfaces to make sure the mesh propagates. And previously, if you did that automatically, it'd be hard to tell like which one is actually mapped up together. So now with the Mesh Controller Explorer right here, if you can't find it when you first open up Femap, it's under Tools, Where'd it go? Huh, I lost it. I thought I knew where it was. Oh, it's right here. It's an option under the meshing toolbox. So let's go ahead and throw it in here so we can actually see it. There's a bunch of solids in here, as you would expect if you're meshing. Let's go into the surfaces that are all paired together. So this pulls in a list of all the paired surfaces, and I don't think you have to do all these pairings manually. There's definitely a way to automatically do this, but the new functionality is you can see which ones are paired together in the table, and when you can like pick and choose which ones to show. So it's actually really cool because you can, like, for example, choose these, right click, and you can change the meshing approach if you need to. Previously, I think you'd have to go into like mesh control. It'd probably be approach on surface, yeah. And then you have to select that surface. Yep. So that's one way that the Mesh Control Explorer is useful. There's also a lot of different categories. So I can actually show all the curves that are connected together or mapped together and paired. So this shows you the curves that it'll map between. And then you can list them. You can show all the curves, that type of thing. And there's a lot of different options. Like this will show you the unpaired free edges that are adjacent to other edges. Maybe if you're looking for problems in your model, like something isn't mapping properly. So yeah, I think this will be really helpful for hex meshing in general. Okay, so another thing I wanted to show you here is if we turn off the solids, let's say we want this to be a mapped mesh. It's a free mesh, it's not very structured. This looks really good, but this doesn't. So we can actually go into the meshing toolbox and change to a mapped mesh. And because we know that all these solids are mapped together, we know that the mesh will propagate through the entire part, even though the solids are all separate. So let's say I want to do like 1/10 of an inch. We can remesh this. And that's a lot better looking, actually. So that's just one example of how you can query and kind of debug if you're hex meshing. Okay, let's dig into the Excel integration. If you go into the model info tree, actually, if you go to File, Tools, and the Function Table Editor, this is where the Excel connection has been implemented for the most part. Let's do just a table versus time. Okay. The one thing to be aware of is that the usual connect to Excel button isn't readily available. It's hidden for some reason. It's under here, send to Excel. And the connect to Excel option is another button that you have to click. So here's my Excel table. Let's say I want a 1 and 1. It's not going to automatically update until you click connect to Excel here. This button only shows up once you actually send to Excel. So now my connection is here. I've made some edits. Let's see if it's going to do this. 2, 2. Wait, I'm not sure that actually worked. Maybe I got confused because I had already made edits. Let's resend it to Excel. Here's our function, our table. Let's connect to Excel. and then start changing something. Huh, that's weird. Either I'm doing something or it's not working properly. Anyway, but this is a good example of just the extra Excel integration that'll be present. I think I'm doing something wrong, but if it's a bug, I'm sure it'll be fixed really fast. So yeah, another thing to note is that if you have like a linear combination you want to do, that's also possible to connect to Excel. So just remember that. Okay, and then the last thing that I'm going to demo is analysis filtering. And remember I said if you're not like using Abacus or ANSYS, you may not want all the options associated with that. For example, if I try to create a new connection property, it gives me all these different cards for MSC Nastran, Autodesk, Abacus, ANSYS. But like, what if I just want to run a linear analysis? I don't even care about any of these tabs. So you can click this button here. It's like a filter with a gear, and uncheck everything, all off, and just turn on linear. Oh, I click cancel. All off, linear. And you can see here it simplifies that whole dialog box. There's not a bunch of tabs. It's a lot more simpler for first-time users. So yeah, I think this is actually a really welcome feature, really smart. So obviously, if you want multi-step structural, you can turn on those, and it gives you the tab and all its values. I think this is also present throughout different let's see, property extensions. Yeah, so if you like filtered out MSC Nastran, this would not show up, or different things would. And maybe some other element types would disappear or appear. So yeah, if you're ever not finding what you need to find, maybe that may be something that you need to look at is, have I filtered out in the past and saved that? Have I filtered out like the 401 options? So, and then I'll show you another way to get to those. If you go to File Preferences, I think it's under Interfaces. Yeah, there's an option to enable analysis filtering, and you can also access the filter from here. This is probably the better way to do it, because it filters for like your whole FEM. If you do it through properties, it may just be for like, it may filter in just those properties, but this will probably save it for your Femap like install, so that next time you open up Femap, it'll still have that filtered selection saved. So just keep that in mind in case like you may hide something and be like, why is this not showing up? Okay, I think that's it for the presentation and the demo. If anyone has any questions, I'm going to check those right now, and feel free to email either of us if there were any like more technical questions on the content, or you'd like to see a demo. Chris and Keith, our director of sales, are both on the line, and if you guys would like to chime in and say anything, feel free to do so now. I'm going to look at the questions and see if there's anything that we should answer.
There was one question that I answered. It was whether or not the old APIs would still be functional after the API changes. I confirmed with Blake before I answered that question. It was that yes, they should be still functional.
Okay. Is that the only question? I think so.
Yeah.
Awesome, guys. Well, thank you for tuning in, and we'll see you on the next What's New webinar. Hopefully there will be some awesome new exciting content to cover. I know I really like doing these webinars and digging into the updates, because I actually use all the updates. So I guess that's about it. And if there are no other questions, I'm going to go ahead and end the webinar. So thank you again for tuning in, and I hope you guys have a nice day.